Hello everyone, welcome to Tech Mac. So today we are going to solve this question, minimum path sum in a triangular grid. So this question is basically an extension of this problem that we have that I have solved earlier, minimum path sum in grid. Okay, so basically we are given a triangular grid and we want to find the path in which we get minimum sum, and other thing that is changed is from this point we don't necessarily have to go to this point, but any of these point we can go. Okay, so this is the problem. So as you can see, if we take this test case, okay, so what happen is we can go this route if we apply the greedy solution, but greedy solution does not work because actually the proper path is this. So to handle this question, we are going to use recursion, try all the possible cases. Okay, so now let's code this and let's understand this, how we can solve this question. So so like, first thing that we can see is, let me take snapshot of this thing. Okay, just a minute. Let me take a screenshot of this. So yes, we have in this question. So we are going. So we know that we have to try all uh, possible conditions. Okay. So if we start from here, so there are two ways. In the previous question we have start from here. So let's try starting from here. So so the question says we can go down, or we can go right. All right. And then from here, again we have two choices. We can go here, here, and then from here, 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 here. So we can see that our base case will be. So if we write base case, okay. Yes, base case. So the base case will be like, if n is the current, I is equal to last index. Okay. So if this condition is satisfied, so we have reached the last index. So on the last index, what we will do is, we will return the current node I and j. Okay. So what is going to happen is, so this will return this 8, and this this 3 this 3 has two options. So either it gets added into this 8 and return 11, all right, or it has another option. So it gets added into this 9 and return 12. And among these two, we will choose the minimum one, which is 11. So 11 comes to 2, and then it comes to 2 from this path, all right, and it has some result that came from this path as well. So which games from 6 and 9. All right, 6 has two options. 6 add into 9, so it became 15, and then 6 became to 9, 15. So it will return 15, and it has to now choose from 15 and 11. All right, so it will give 11, and then one result will came from this path. So this is going to happen right now. So this is the base case. All right. And now we will write This is base case. Now we will write main logic. So logic is uh, okay. So in this, initially we are on the cell. Initially we are on the cell 0 0. On this cell we are initially. So we have two choices for every cell. So we can go down, down. We can go down. So when going down, we will take the current element. All right, grid I and J. We have took the current element, and now we will get the result of moving down. All right, I plus 1 and then J. That's great. And then we will go diagonal. Diagonal is this way. Diagonal. All right. So in this also we are going to add this sum grid I. So this grid I is this sum, and this is the sum that we get from this function call grid J. All right. And then F I plus 1 and then J plus 1. All right. Now this is going to return the minimum of both these values, down and diagonal. All right. So this is our main logic. So if we going to see the code, so the code is the same. If we see, so what happened is this is the base case, this is going down logic, and this is going down, and then it's returning. So now we can memorize this function. All right. So to memorize this, we will define a DP array I and J 2D array. So in which this value, any particular value, gives the gives the result of visiting this cell from 0 comma 0. Okay. uh, uh, did you guys got it? Okay. So this means that suppose we have stored this result, we have got this result. So every element represents, so what is the minimum path sum when going from this cell to this cell to this cell to this cell, every cell. All right. So suppose we visit this cell, okay, and then we visit this cell, then we have this result of this cell, and from this cell again we visit this cell. So this is the redundancy that we are going to eliminate, because we don't want to visit the cell twice. Okay. So what we will do is we will first check over here. Let me use this marker to memorize. We will first check using this. So if we have dp I comma j defined, then we are going to return from this only, because we have already this answer dp I j. And now before returning what we actually going to do is we will store dp I and j over here, and minimum of down and diagonal. All right. So this is how we are going to approach this problem. Now how we are going to tabulate this result. This is going to tabulate this result. How we are going to solve this problem using tabulation. Okay. So let me again take this thing. Okay. This is not complicated at all. So now we are going to tabulate this. So what we need to do? So in tabulation we have the result of some base case, and upon that base case we will build result, further results. All right. So in this, if we see, so suppose we have a suppose we have a one. Suppose if if the array is only this, okay, so the result is only this, all right. And if it is the last visiting the last cell, minimum cost of visiting the last cell, all right. So in this we are going to store the result of initially in the DP array. Every element is as it is of the last cell, because if we are visiting this cell, we are visiting this cell, so the result is this only. If we are visiting this cell, the result is this only, the result is this only, all right. Are you getting? Suppose it's like if we are going to visit this cell, then the result will this only, right? Okay, so first now we will take it, write it, the code. If okay, for for j is equal to 0, j is less than n, and j plus plus. So j plus plus and j less than, right. So now we are going to store this result dp 0, not 0, dp n minus 1 and then j. Oh, okay, let me check, confirm once. Dp n minus 1 and then j. This is the last row we are going to store. dp n, n fuck, sorry, I will add in that part. dp, and then we are going to define j, and we will give it, oh man, we will give it grid, and then I, and then j, all right. So this we have already made a dp grid, okay, corresponding to this, in which last elements are 8. We will go from bottom to up, opposite direction, in the 8, 9, 6 and then 10, all right. Now you will see what is the logic, how we inverted that logic above. It is the same. So we are going to visit this cell, all right. So we have answer to this cell and answer to this cell, so we will take minimum of these two, okay. And now for this cell we have answer to this cell and answer to this cell, we will take minimum of these two. And for this cell we have answer of this cell and answer of this cell, and take minimum of these two, and that's how we reach the top cell. So let me write that logic as well. So we will start from this cell, all right. From this cell we are going to start. For I is equal to n minus 2 and I greater than is equal to 0, and then I plus plus, all right. And now uh, for this is for the I part, all right. And now for this cell we will start from 0 to I, 0 to I, this cell, because this is a triangular grid, right. So we will take first with this cell and then this cell and then this cell, all right. And then I minus 1, 1 less than I. Let me check over here as well, or we can, yeah, we can go from here as well or here as well, both are the same thing. So for mm, j is equal to I and j is greater than equal to 0 and j plus plus, all right. Now if the answer of down is current grid cell I and then j and plus plus, visiting using the DP array to get the result of moving down. J. All right, and then move up is equal to grid I and j, and using the DP, not up, basically it's diagonal to DP I plus 1 and j plus 1. So now answer of the current cell of the DP I and j is minimum of these two, minimum of down and diagonal. Okay, got it? And in the end we will going to return dp 0 and 0. So this is how we are going to solve this problem using tabulation as well. So here is the code, similar code, nothing new over here. Okay, so this problem has been solved. Thank you for watching.